So before we jump into our first actual lesson that isn't review, we just want to go over how your calculator works first, especially because we're online right now. You'll kind of have to figure this out on your own. So I just want to give you a couple tips so that you can get through this trig unit understanding how to use that calculator, because that's going to be very important, especially in this unit. So obviously everyone's calculator is going to be a little bit different. So it's important to figure out how your specific calculator works. You should obviously have a calculator. If we do go back to in school, it is expected that you have your own calculator. So if we're looking at an example here, it says, how do you find the value of the cubed root of 17? So there's a little 3 there on top of that root sign. So again, you're going to want to try to type these different methods in on your calculator as we're going along, so you can tell which way works on your calculator. So if you have an older calculator, you're likely going to have to use these 3 keys. So you would first type in 17, then you would type in your button. So it's going to have X on top of that root sign and a Y underneath. So you might have to click shift or second to get to that button, but you should have that button on your calculator. And then lastly, you would type in 3. Okay, some of the other calculators, you might just have a cubed root button on there. So again, you might have to click second or shift to find it, but you would just type in that cubed root button and type in 17 and click equals, and that should give you your answer. Okay, less likely, but possibly if you have a different calculator, you may need to use these buttons here as it shows. So again, you're obviously going to include that 17 and the 3, but you might have a button that's 1 over y to the power of x or 1 over x to the power of y. So again, you type in the 17 first, find that button on your calculator, and then type in 3, and then click equals. So hopefully you were able to kind of find what options work best for you for your calculator, and you should have got the answer of approximately 2.571. So make sure, again, you're just going on your calculator, making sure you know how to get there, and you get that correct answer. If you're still struggling, obviously we can have a quick meeting and we can sort out how to use your particular calculator. All right, so a little bit more on this. So using your calculator in trigonometry. So it says complete the following chart by experimenting on your calculator. If you get stuck, try asking a friend. Obviously, we don't really have that ability. I guess you could text your friend, or you can send an email to me, or we can have a live meeting just to figure it out. Okay, so this is a chart here. It has a question, the answer you should get, possibly what you're going to type in on your calculator, and then you're going to fill in that last column with specifically what you need to type in on your calculator to get the right answer. So if we are asked to find sine 60 degrees, so that's something we would use if we're looking for a side length. Okay, we're typically going to round to about 4 decimal places, as you can see here with that first answer. There's 4 decimals after that. So possible suggestions on how to get this answer. So you can try either of these 2 bullet points and then just write down whichever one worked better for you. So on my calculator here, I type in sine then 60 equals. So for me, it was option 2. So I did sine 60 and equals. So those were my 3 steps on my calculator to get to that answer. Okay, the next one here, we have 3 sine 60. So that's the same as 3 times sine 60. Okay, and we should be getting an answer of 2.5981. Okay, so now we're looking at the suggestions. How are we going to get that answer? So we're either going to press sine, then 60, and multiply it by 3, or type in 3 times 60 and press sine followed by the equal sign. So again, you're just doing this on your calculator. I know that I have to type in sine before 60, so I'm going to try the first one there. So sine, then 60 times 3, and 2.5981. Beautiful. So for mine, I did sine 60 times 3 equals, and I was able to get that correct answer. Okay, next one here, it says find theta if sine theta equals 0.5. So this is where it gets a little bit more complicated. So again, that little sign there, it's not super important that you know, but that's what we call theta. I'll write it on the top here just so I have a bit more room. Theta, and it's just basically a variable. It just stands in the place of an angle measurement. So when we have something like this question, it's when we are trying to find an angle. Okay, so we should be getting an answer of 60 degrees here. So in order to do this, we have a couple of options. Okay, so on your calculator, you're going to start by keying in 0.5, then pressing cos to the -1. So in order to get that cos to the -1, which you'll hear me refer to as the inverse of cos, you may have to click the second function or the shift key. It is typically on like the second of the cos. So if you find your cos button and you know where your second or your shift button is, you should see kind of on the calculator there, it should say cos to the -1. Okay, so that's the first one, or the first option. You could also potentially press cos to -1, then key in your 0.5. And don't worry about that last one because we're probably not even gonna deal with that. Same with this one. Okay, so oh, look at me, I'm looking at the wrong one. Sorry, we skipped one. We'll go back up to this one. So same thing, we're trying to find an angle here, but we have sine theta. So everything I said, same thing, except we need to use that sine to the -1. So the options for those two, or actually all three of these are going to be the same. So typing that in on your calculator, starting with that first one. So again, you can try the 0.5 first and then click your inverse sine button. For me, that gave me an error. So I know that's definitely not the way my calculator knows how to do this. So I'm going to try to type in the inverse of sine first and see if that works. And it does. I get 30 degrees. So for me, I have to do sine -1, which again, I get there by doing the second function of sine. I type in my 0.5 and I click equals. Okay, it's likely going to be the exact same thing. Well, it's not likely. It is going to be the exact same thing if you're trying to find the cos theta of 0.5 or tan theta of 0.5. You're just going to use different keys. So again, in order to find that sine -1, cos -1, tan -1, you should just be able to click second or shift and then sine, cos, or tan, depending on which one you're using. Obviously, those are different trig ratios, so you need to make sure you're using the correct one. So for me, again, this time I would do cos -1, 0.5 equals, and here I'm going to do tan -1, 0.5 equals, and I'm able to get all of these answers over here. Okay, so again, if we're asked to find theta, we're looking for that angle measurement. Okay, so hopefully that helps you a bit with your understanding of how actually your calculator works, because that's going to be obviously very important. So I'm just going to pull up the second part of the note here. Here we go. Edit. We'll use a different color. All right. So now we're jumping into our actual formal first note that is, like I said, new. it potentially is review, but it's part of this curriculum. So we're starting with those primary trigonometry ratios. So the first thing we're going to look at is how to use these to actually find a side length. We are going to be focusing on these trig ratios for a couple lessons here. So first thing, there are 3 primary trig ratios. So again, I'm going to try to write as small as I can, but I apologize that it's not super clear. So we have our sine, our cosine, and our tangent. This is an n, tangent. So these primary trig ratios can only be used with right angle triangles. So we need to have a right angle, and a right angle is a 90-degree angle. Okay, and we only need one, but we have to have at least one 90-degree angle. So right angle triangles have a couple different features here. Okay, so the first thing is they obviously have a right angle, which we can see here on C with that little square. Okay, we can see that that's our right angle, so we know that we can use our trigonomic ratios here. Okay, the next thing is being able to actually label those sides. So the side that is across from your right angle is always going to be your hypotenuse. Always going to be your hypotenuse. Okay, so that's the one that's across from the right angle. And it's also going to be your longest side. Okay, when you're labeling the other 2 sides, so there's adjacent and there's opposite. So those 2 sides are going to basically change depending on what angle you're looking at. Okay, so specifically you're going to be asked to find a particular angle. So say we're asked to find angle A. So we're just going to call that theta. Okay, just that little symbol that we learned on that last slide. Okay, once we know where our kind of reference point is, we can label that opposite and adjacent. So opposite, guys, just as it says, is going to be opposite of the angle we're looking at. So if I draw a straight line across from the angle I'm looking at, it is going to point at that opposite side. Opposite. Okay, so that one is always going to be across from the angle that we're focusing on. Okay, so in this case, angle A. Whatever side is left over is going to be our adjacent side. So it's our adjacent side. Okay, so the adjacent side is always going to be beside that angle of focus. Okay, it's not across from anything. It's just going to be, you can think about it as the leftover angle or the one that is beside the angle we're looking at. Okay, so in order to remember the different trig ratios, we obviously have an acronym. I'm sure you've heard it before, but we refer to it as SOHCAHTOA. So SOHCAHTOA. Okay, so that is the acronym that we use to remember our trig ratios. So again, even for me, right now, these days, when I'm doing math, I always just write that on the top of my page so that I can remember what sides affect the different trig ratios. Okay, so just to write those out, obviously we have O, H, and A here. So those are going to represent opposite, hypotenuse, and adjacent. So for sine is OH. So that means we have opposite over hypotenuse. Okay, cos is A over H, so we have adjacent over hypotenuse. And lastly, tan, we have O over A, which is opposite over adjacent. Okay, so it's going to be important, obviously, to remember those so you don't get them confused in any way. All right, so let's do a couple examples here, just 3. Okay, so And like I said, the title of this note is working with those side lengths. So that is obviously what we're going to be focusing on here. So it says find the length of side A to the nearest 10th. Okay, so the first thing that you need to know is to label the sides. If it asks you for side A, and as we can see on our diagram here, it doesn't actually show us what side is A. It's the one across from angle A. Okay, so across from angle A, so that means this side would be A, this side would be B, and this side would be C. Okay, see how those are across from the angles. We always label our angles with capital letters and our side lengths with lowercase letters. Okay, so looking at these nicely laid out steps here on the right hand side of your page. So we just have 3 simple steps to solving. So the first one is to label the sides of your triangle relative to the given angle. Okay, so we've started with that. We obviously labeled them A, B, C, but we also want to label them with our adjacent, opposite, and hypotenuse. So I'm just going to do that in a different color. Okay, so the angle that we have to use here, our angle of reference, our angle that we're focusing on, is this 25 degrees. Okay, we're never going to make that 90-degree angle our focal point. Okay, it doesn't work like that. It has to be one of the other two. Because we don't have angle A, we obviously can't use it. Okay, so our focal point here is going to be that 25 degrees. That means we need to label all of the sides based on that, the placement of that value. Okay, so remembering from above here, our hypotenuse is always across from that right angle, right? So if I look where my right angle is, where my little square is, across from it is C. So I'm going to label that my hypotenuse. Okay? Across from the angle that I'm dealing with is always going to be my opposite. So again, if I draw a straight line here, it would lead me to that side, and the leftover side is going to be my adjacent. Okay, so step 2 says to determine which trig ratio to use, sine, cos, or tan. Okay, so this is where people tend to struggle, is determining which ratio we actually need to use. So basically, in order to determine this, we need to have just one variable, right? We need our other 2 pieces of information filled in. So in this case, all the information we have is an angle and a side length. So we need to include those in our trig ratio. Okay, so we know right away that we need to use the hypotenuse because it's the only side length we have. So right away I can cancel out tan. I know I'm not going to be using tan to help me solve for this side length A. Okay, the second part in determining that is that you need to include the side that you're looking for. Okay, so I'm looking for side A, which is my adjacent side. So right away I know I need to use the trig ratio that has the adjacent side and the hypotenuse. Okay, I look back up, I can see that I have to use cos. Okay, so I'm going to start by just writing it out. So I have cos B. The reason I have B is that is the angle measurement that I actually have. My adjacent side we're just going to call A, and my hypotenuse is 12. Okay, so we determined what ratio, and I've moved already on to step 3. So step 3 says set up the equation with the unknown side and solve. Okay, so our last step here is to solve. And actually, I should have written in for B that angle measurement. So that's fine. I'll just do another step. I'm just going to try to keep it as small as possible. So we actually have cos 25 equals A over 12. Okay, at this point, we are just simply solving our equation. Okay, when we are solving an equation, which again is review, you hopefully kind of have a grasp on that from what you just did over the last couple days. We need to isolate the variable, right? That means we need to get A all by itself, And in order to do that, what we typically do is we use opposite operations, right? So if I need a all by itself and a is divided by 12, I need to do the opposite of division. So instead of dividing, I'm going to multiply by 12, okay? 1 over 12 times 12 is just 1, so these are going to cancel out, and I'm left with just a on that side. But what's important is what we do to one side, we have to also do to the other. So I also need to multiply my left side here by 12. Okay? At this point, it's kind of personal preference. You could absolutely type in your calculator 12 times cos 25. Okay? Or you could solve for cos 25 first. Okay, so you should get 0.9063 and multiply that number by 12, and you should get 10 point, we'll just do 2 decimal places here, 10.88. Okay, my calculator says 10.875 because 5 is obviously 5 or higher. I'm just going to round the second decimal point there from 7 to 8. Okay, oh, and the question actually says to the nearest tenth, so what we would actually do is we would round that to just 10.9, okay, because a tenth is just 1 decimal point. So we have now 10.9 equals A, and we're dealing with centimeters, so we want to include that. Okay, so let's do a couple more examples just to make sure you have a grasp on this. So example 2 again, find the length of side B to the nearest tenth. So again, we're going to start, we just want to label those sides. So obviously B, again, it's across from the angle B. The A and the C are less important here because we're still going to label our hypotenuse, opposite, and adjacent. So again, that's the next thing we're going to jump into. We know that the hypotenuse is always across from the right angle. So that would be this side here. We know that whatever angle we're given is the angle of reference. Okay, so across from the angle we're given is going to be our opposite side, which will be B. And obviously whatever's left over will be our adjacent. All right, so that was step 1. Again, step 2, figure out what ratio we need to use. Okay, so here we can see that we are given the hypotenuse, same as before, and we need to find the opposite side. Okay, so all we have to do is look for the trig ratio that has opposite and hypotenuse. Okay, so we look up, we see that that ratio is sine, so sine is the one we need to use. Okay, you are welcome to write out the equation. Really, you should write out the equation. For me, I just don't have a lot of room, so I'm just kind of choosing what I can fit here. So again, we decided on sine. Now, step 3 is to set up that equation with the unknown side and solve it. So I'm going to plug in my angle measurement, which is 10. Okay, and then sine is opposite over hypotenuse. So my opposite is my variable, just b, and my hypotenuse is 15. So again, this looks very similar to the one above, right? At this point, all we need to do is solve for b. In order to do that, we're going to use our opposite operation. So again, we have b divided by 15. So in order to get rid of that 15 on the bottom of that fraction, I'm going to multiply by 15. Okay, those are going to cancel out. What I do to one side, I have to do to the other. So I have 15 times sine 10 equals b. So again, for me, I like to do sine 15 equals, get a nice number there, then multiply that by 15 to get my answer. Again, it's asking us to go to the nearest tenth, so my calculator is telling me 3.8822. Again, the tenth is just 1 decimal place, so we look at the one beside that, which would be the second decimal place. If it's 5 or higher, we're rounding up. If it's 4 or lower, we're rounding down. 8 is obviously higher than 5, so I'm rounding up. So my B is equal to 3.9, and this time we're dealing with meters here. Okay, and let me just make sure I've subbed everything in there. So sine is opposite, which was our B, over hypotenuse times 15. Perfect. Just want to make sure I typed everything in here. Sine 10 times 15. Oh, see, I made a calculation error somewhere. Thought I did. Okay, and hopefully you got the right answer on your calculator, because again, you should be kind of following along as we go here. So I typed it in my calculator. Again, I must have made a calculation error. Always best to double check your work to make sure you don't make those errors. And now I'm seeing that my answer should be 2.6 meters. All right, last example here. So it says find the length of side A to the nearest 100th. Okay, the nearest 100th. All right, so again, we're labeling our sides. So opposite from our right angle is always our hypotenuse. Okay, we figure out what's our angle of reference. It's obviously the angle that we know, right? So we can see that that's angle B. Across from the angle we know is always our opposite. And what's left over will be our adjacent. Okay, so we can see, what is it asking us to solve first? Angle A. So this will be angle A, right? Across from A will be this side length. Okay, it's important to label that too, because we need to know, obviously, what side we need to include in our calculation. Okay, so we need to find A. We're given the opposite, and we know that our angle is 40. So we need to use the trig ratio that has opposite and adjacent. Okay, so that is obviously going to be tan. Okay, so tan, again, the equation is tan theta, or tan the angle, is equal to the opposite side length over the adjacent side length. So we need to make sure we're not just putting in tan equals. Okay, it should be tan theta if we're solving for an angle, which we'll get there in the next lesson, or tan, fill in the angle that you have. So we have the angle of 40. Okay, and that's going to be equal to opposite over adjacent. So my opposite is 35. And my adjacent is just simply A. So we can see that this one looks a bit different than before, right? We now have the 35 on top instead of on the bottom. Okay, so what we're going to do is we're going to solve it the exact same way. All right, we're going to use opposite operations, to isolate A. Okay, so in order to do that, again, we don't want A on the bottom of a fraction. Okay, our goal is to get it all by itself, and we can't get it by itself if it's on the bottom of the fraction. So what we're going to do, just like we did before, is we're going to multiply both sides by A, right? These will cancel. So now we have A times tan 40 equals 35. Okay, again, we need to get A all by itself. Now it's on my left-hand side. So we use opposite operations. If I have anything times anything else, the opposite of multiplication is going to be division. Okay, so what I need to do is I need to now divide by that tan 40. Again, I'm not dividing by A because, again, my goal is to get A all by itself, right? So I need to get rid of anything that is attached to A. When I do tan 40 divided by tan 40, I'm just going to get an answer of 1, which means we can just cancel these out. What I do to one side, I have to do to the other. So I must also divide my other side by tan 40. So now what I'm left with is A equals 35 divided by tan 40. Notice from our original equation, all we actually had to do was switch the placement of these two. Okay, so if you know how to solve an equation, you should be able to get there. But if you would rather, you can just remember that those will have to switch locations, right? Tan 40 and A just simply ended up switching locations. Okay, so let's continue to actually solve this. So again, now we have A equals 35. On my calculator, I'm just going to type in tan 40 or 40 tan. Again, depends on your calculator. You should get approximately 0.8391, we'll say. Okay, so now we need to do 35 divided by that answer. Okay, and I'm just going to shoot it up here. You should get approximately 41.7. And this time, again, we look over, we're dealing with millimeters, so we want to get those communication marks. So we want to include that in our answer. So the side length of A is 41.7 millimeters. Okay, obviously the first two examples here are a little bit easier, but it's important to know how to do that trickier one as well. Okay, so this is the end of this lesson.